Okay, today we're going to be working with section 2.6, which is solving a system of equation with matrices. So using kind of really what have we been working with our matrices and really kind of nice section that would ties everything in. Why do we do matrices and how it's going to help us and why did we start with a system of equations? So today our main goal is to use matrices to solve a systems of equation. Solving a quadratic system of equations will be on our next video. So that's coming. And we'll talk about kind of taking this idea to the next level. So we're looking at this matrix operation, and I know you might not understand what I have here in the box, but this is what I want you to be able to come back and refer to. So this is kind of the real big picture. When we're given a system of equations, how do we set that system up with matrices? And then how do we kind of move things around to solve it? Okay? So big picture, and I'm going to move this down because what we're going to do in the big picture is we're going to have this matrix, all right? And so it's kind of like this matrix here. And we're saying, okay, our matrix A multiplied by our XY matrix. And if you notice my matrix A, where I got all of these numbers here for my matrix A, came from the coefficients in my problem. So it's all the coefficients of my problem. And if you notice, like if we did matrix multiplication here, so if we did matrix multiplication and we multiplied these two times these two, we would get back here, that's what we would get. We would get 8x plus 2y. So that's kind of how you do matrix multiplication, and this is a little bit of doing it backwards. Okay? And then I got the 2 and the negative 23 from my constants and my equal sign. All right, second equation just would be this, 3, negative 4 times the xy. So it's just another way to write it. So we have here, I'm back down here now, we have this a times the xy, and we know it equals the 2 and the negative 23. And really what we're going to think of this is we're actually going to think of this as our matrix B, another matrix. Well, a times some variable equals b. So if I just said ax equals b. Really, if we were able to, what I would say to solve this for my variable or variables is I'd want you just to divide by a on both sides. Well, with matrices, it's not so easy to do division. So the way that we show or that we write division with matrices is we say A inverse times B. Okay? And that's what we have shown right here is A inverse, that first matrix inverse times B. Now, we can do this on a graphing calculator. We can do that inverse times our second equation. So I'm going to show you here. We're going to solve this here. I'm going to need more space. So we want to solve this. So in solving this, it's all about the setup. So what I'm going to want you guys to do for the setup here is I want you to put your original values into a matrix. So we're going to have our XY part of our matrix. And I'm going to put 5, 2, 1, negative 1. Now we need to think of it as really it's being multiplied by XY, that's what we're talking about is our XY. And that equals negative 15, negative 3. Okay, so what we want to do now is we want to say how do we solve it? We can't divide by both sides, but we can. We show that division on both sides by doing, excuse me, that's there, the inverse. So we want to take the inverse of our first fraction times our second fraction. Now we can do the inverse by hand and we know how to do that or we kind of seen it done. It takes some time. It's a little bit of a kind of a pain to do it. So we're going to use our graphing calculator to do that. So now here is our graphing calculator, all right? And we are going to put in the graphing calculator this, we're going to call the 5, 2, 1, negative 1 our A, and we're going to put into B our negative 15, negative 3. And so let's put that into our graphing calculator here. All right. So we'll start with going into our matrix function. We're going into edit. And we want to put into A, we want to put our 2 by 2 matrix. So I'm going to do that. I'm putting my 2 by 2 matrix and I'm putting in the matrix 5, 2, 1, negative 1. And then the one thing we have to remember to do after we've done all that is to quit out. And that's the one thing that students usually forget to do. Now we're going to put in our B matrix. So now we're going to go to Edit, and we're going to go down to the B matrix. We're going to hit Enter. Now this is a 2 by 1 matrix, not a 2 by 2. So we have a 2 by 1 matrix. Now let's say you got it wrong and you put 1 by 2 matrix. You can go back and fix it and put back in 2 by 1 after you look and see the prompts that the calculator gives you isn't correct. So now that one was our 15 and a -3. Again, we're quitting out. So now our goal is to take the inverse of our A matrix multiplied by the actual of our B matrix. So we're going to go back and we're going to get the name of A. So there's the A matrix. We want the inverse, and the inverse is right there. I have it highlighted in red right now, that inverse key. You just hit it without hitting second first. So it's really that matrix key without hitting second. Now we're going to go back into the matrix. So now I hit second matrix, and I'm going down to B, that I want now the B equation. So A inverse times B, and I hit Enter. Now I'm getting kind of, and I think it's because I just kind of came up with this equation off the top of my head, I got kind of a goofy answer. That is my X and my Y. Now if I hit Math, Enter, Enter, I'll get it in fractions. So my X was 9/7 and my Y is 30/7, 30/7. All right, so we have an answer. This would have been a real big pain. So it was 9/7 and 30/7. Let's see if we can get a problem with a little bit better answer. I just kind of had a challenge problem there. I think I just made up the problem, but let's see if we can get a better one here. Sorry about that. This one we actually could solve, and we have solved problems like this when we were solving this by hand, and it was turned out to be a really tough one to solve by hand. But putting it into a matrix formation isn't bad at all. So our first step is coefficients 4, -2, 4, 3, 1, -1, 2, 4, 2. I just had to really make sure I had all of my coefficients in order, the X and the Y's and the Z's in their different columns. So I had to make sure I had my X, Y's, and Z's all in order. And then my constants over here is 28, 12, and 4. Okay, so what I'm going to do is I'm going to put into my calculator here, into A, 4, -2, 4, the 3, the 1, the -1, the 2, the 4, the 2. I'm going to take the inverse of that and multiply it by my B, 28, 12, and 4. Okay, let's go ahead and do that. And actually, I'm not going to show you the process of putting it into the computer. I'm going to pause it here for a minute. I'm going to put them all into the calculator, and then I'm going to show you how to do that. So I want to show you that I have put in my two matrices. That under A matrix, I put in the matrix that we were just looking at, the 4, the -2, the 4. That's our matrix there. Under the B matrix, I wanted to assure you that what I have under there, I entered in all of the different numbers. You just didn't have to see me enter in. Was their constants are 28, 12, and 4. And what we want to do now is we want to take our A matrix there, and we want to take the inverse of it. Oops, I made a mistake. I'm going to delete that. Sorry, I had a squared and I hit the wrong one. Here's my inverse. Oh, I went over. Let's delete that. See if I can get it in the right spot. I didn't delete enough. There we go. A inverse. Oh, I'm going to have to start over, guys. Sorry. All right. Matrix. I want my A matrix. I want to take the inverse this time. Now I want to multiply it by my B matrix. That looks a little bit better. There we go. And when I hit equal, it gives me the answer. So my answer to this is that X must be 5, Y is -2, and Z is 1. So it was 5, -2, 1, all right, is our answer. So we can write it like this. I'd be okay with that for an answer. If you remember before, we wrote the answers like this. I don't care which direction you write it. You need to know either vertically, I need to know that it's an X, Y, Z, or this way it would just be assumed that you have X, Y, Z. I'm going to go through one more example with you and to show you just one more how you're going to set this up. I know a lot of you are thinking, do I have to write it out each time that with the XYZ? No, not necessarily. What I'm going to be looking for on the bare minimum of what you're going to have to show me when you're solving this. I want to see what um, matrices you're using. So you know it's going to have to be one matrix inverse multiplied by another matrix. So I'm okay if you just go through this, but this way it would help me to diagnose if you plugged in your matrix wrong. And are you writing down the wrong matrix? Be careful of your negatives. But I'm okay if you skip the step where you're showing it's being multiplied by X, Y, and by X, Y, and Z. I'm okay if you just show it this way. Okay. So now we have to, again, we're going to go into our graphing calculators and we're going to enter this in. So all right, so now we have to enter that into our graphing calculators. So I'm going to go back to my matrix. I'm going to enter in a new A, and I like to just keep it in A. I'm going to enter in a new A. We still have a 3 by 3. And my new matrix, it was 3. It was -5, 1, 1, -3, -2, 5, -6, 3. And the big thing I see students forgetting to do is quit out. We're going to enter in our B matrix now. And that matrix was 9. It was still a 3 by 3, or 3 by 1, excuse me, 9, -8, and 15. That was our problem, and quit out. Now here's kind of a quick trick I wanted to show you. Now remember how before the last operation we asked this calculator to do is to take A inverse B. Instead of trying to go through the matrix, I can hit second, enter, and look what shows up, A inverse B. But my new A is in there and my new B is in there. So now I can just hit enter and it's going to give me my new answer. It's kind of a slick little thing. So our answer is -6, -4, 7. So the answer to this equation here, -6, -4, 7. That is my answer. Circle it and call it good. I'm not going to be requiring a lot of work to be shown because my expectation is you're doing this on your graphing calculator. Hope this helps.